Let's talk about compound interest. Now, Albert Einstein calls compound interest the eighth wonder of the world. So obviously it's a big deal. We're going to talk about compound interest in the context of money, but you know, it's true for education, it's true for relationships. I mean, compound interest is compounding is kind of a big deal. So the future value of an investment is how much you'll have later. So FV stands for future value. This is a future value. This is how much you will have in the future. Okay. Now the principal P, that's the amount you invest. Okay. R is the annual interest rate. The key word here is annual. So this is sort of, if you had invested for a whole year, this is how much interest you would get as a proportion to your initial investment. Okay. The time T is always measured in years. And let's take a look at this formula right here. So one thing you'll see is this number N. N is the number of times we're going to compound during 1 year. So I should probably label that. And this is the number of times you compound during a year. And when I say this word compound, I really mean you're just calculating interest. So for different values of n, you're going to calculate interest a different number of times throughout a year. All right. So you could compound annually. If you compounded annually, that would mean that you compounded once per year. Semi-annually means that you would compound twice per year. Okay. Quarterly, a lot of the finance stuff is calculated quarterly, and that happens 4 times a year. So your N would be 4. Um, monthly means you compound 12 times a year because there's 12 months in a year, so that's 12. And daily, there's 365 days in a year, so that's 365. So N takes on different values depending on how often you calculate the interest. When you look at this compound interest formula, this R over N, remember R is the annual rate, but if you're compounding more often than just once per year, you don't want to have the annual rate here. You want to divide by the number of times you compound. So if you compounded semi-annually, for example, then this would be the annual rate divided by 2. If you compounded monthly, this would be the annual rate divided by 12. Okay, so if you look at this exponent NT, NT is the number of times we compound during the loan. So the way you could think of this is, let's say N was uh, 12, meaning that you compound 12 times in 1 year, and T was equal to 4, then the total number of times you would compound would be N times 4, or 12 times 4. So you'd calculate your interest 48 times. Okay. So when you plug in all the appropriate numbers here, you're going to get the future value of your investment. So that'll be how much your investment is worth in the future. So let's take a look at an example together to better understand this. Let's calculate the future value of a $1,200 investment. So that means that our initial investment, our P is going to be equal to 1,200. Okay. If it's compounded over 4 years, that means that our T is equal to 4. And when they give us this 2% interest, that's the annual interest rate. So R is going to be equal to 0.02 because we have to change that 2% to a decimal. And what we're going to do is we're going to calculate the future value with different compounding periods. Okay, so let's say you did it annually. Then our future value would be equal to the principal, which is $1,200, times 1 plus, now we want to adjust our annual rate. Well, our annual rate is 0.02, but we're only doing it once per year. So actually, there is no adjustment needed, but I'm going to divide by 1. And then we're going to do 4 times 1, which is 4. So that means we're only going to compound 4 times, once per year. So if you calculate this using a calculator or some spreadsheet program, you would get $1,298.92. Okay. Let's say that instead of compounding just once per year, we compound twice per year. Then our future value would be $1,200 times 1 plus, this time we're going to take our annual rate of 0.02, but divide it by 2, because we're compounding every half year. And the number of times we compound will be n, which is 2, times t, which is the number of years. So we're going to compound a total of 8 times. We're going to recalculate our interest 8 times. And when we do this, we're going to get a slightly higher number. We're going to get $1,299.43. So we can see that if you compound more often, you're going to have more money at the end. If we now see how much we'll have after compounding quarterly, our future value will be calculated by taking our principal, which was $1,200, times 1 plus our annual rate of 0.02. This time we're going to divide by 4 because we're compounding quarterly, so that interest rate gets cut into 4 pieces. And the number of times we compound will be 4 times a year for 4 years. That's a total of 16 times that we compound. And we are going to get $1,299.69. So what do we notice? We notice that while we're compounding more often, the rate at which we're compounding in some sense decreases. So like you compound more frequently, but the amount of interest, the interest rate, the effective interest rate decreases because you're compounding over less time. Okay. Let's finish off this example by looking at a couple more. So let's calculate the future value if you compounded once a month. So if you compounded once a month, you take your principal of $1,200, multiply that by 1 plus our annual rate of 0.02. This time we're divided by 12. How many times have you compound in total? 12 times a year over 4 years gives you 48 total times that we compound. And we are going to get $1,299.86 by the end. Finally, let's try compounding daily. So there's 365 days in a year. So our future value will be $1,200 times 1 plus our annual rate of 0.02 divided by 365. 4 times 365 is 1,460. If you stick all of this into a calculator, you would get $1,299.94. Okay. So then you could keep going and take this further and further. Instead of compounding daily, you could compound hourly, you could compound by the minute, you could compound by the second, and eventually you say to yourself, what happens if I compounded in a continuous way? In other words, what happens if at every single instant I was compounding? Well, when you do that, you kind of introduce the idea of limits. Luckily for you guys, there's a formula that will give you the amount you're going to have if you compound continuously. the continuous compounding interest formula basically looks like this. Your future value is going to be equal to your principal, P, times our letter E, that 2.718, times to the RT power. Okay, so I'll put a box around that. And let me highlight this because it's kind of an important formula for us. Okay, so we can see that if we do things continuously, you're going to get, you're going to introduce E. Now, how can we see this? Well, we see this by looking at limits, right? So let's find the future value of what happens when we take the limit as n goes to infinity of p times 1 plus r over n to the nt power. Okay, now what we're going to do is we're going to introduce something a little bit extra. So check this out. We're going to take the limit as n goes to infinity. We're going to have our p stays there, but this will be 1 plus r over n. Now we're going to change the power over here. We're going to have a n over r, and then we're going to raise this whole thing by rt. So all I really did was I looked at this exponent over here and I divided by r and then I multiplied by r. So here I divided by r and then I multiplied by r. So when you multiply these two together, you get the same nt over here. All right. And what can I do next? Well, I could take this p. This p does not involve n at all, so I can factor that out of my limit. So this becomes p times the limit as n goes to infinity, 1 plus r over n to the n over r, all raised to the rt like this. Okay, next I'm going to make a substitution. What I'm going to do is I'm going to let n over r be equal to m. And when I make this substitution, my limit looks like this. It's p times the limit. Now I have m go to infinity, and I got 1 plus 1 over m. My power up top there becomes an m, and then I have the rt exponent there. Now, when you look at this inside part right here, this inside part right here in green, this is the very definition of what E is. So remember, we had a limit definition. E was equal to the limit as n goes to infinity, 1 plus 1 over n to the nth power. So I just let my m be equal to n, and we can easily see that you're going to get that green part becomes an e, and then that's how we end up with p times e to the rt. All right. So this concludes our video introduction on compound interest. Take care, everyone.